students. Today we'll complete the topic wall timing diagram. As already we have completed the components of IC engine in previous lecture, today we'll see what is wall timing diagram. As you know, in 4-stroke IC engine, we have inlet wall, outlet wall, and spark plug in case of SI engine, and fuel injector in case of CI engine. Wall timing diagram helps us when the valves opens and closes, when there is a spark plug ignites, or when there is a fuel injection in case of the CI engine. Here in the diagram you can see there is a different circles are shown. These are nothing but the wall timing diagram. Here you can see here it is the TDC and here it is the BDC on the screen. TDC is nothing but the top dead center and BDC is the bottom dead center. In case of the vertical IC engine, when piston is near to the cylinder head, then it is called as top dead center. And the position of piston away from the head at the lower, then that position of the piston is called as bottom dead center. So we have also seen there are 4 strokes like suction, compression, power and exhaust in case of 4-stroke engine. So here we'll start from IVO, that is when inlet valve opens. You can see the IVO is at the TDC, means when piston is at top dead center, inlet valve opens and piston starts moving from top dead center to the bottom dead center. So during this, when inlet valve opens and piston moves from top dead center to the bottom dead center, suction of fuel and air mixture in case of SI engine, and in case of CI engine only air is taken inside the cylinder or combustion chamber. During this movement of piston from top dead center to the bottom dead center, crank completes 180-degree angle and piston completes one stroke. That's why you can see the green color line IVO, inlet valve open, to IVC, inlet valve close. It is there for 180 degree from TDC to BDC. At the end of the stroke, when piston reaches to the bottom dead center, inlet valve gets closed and suction stroke completed. The next stroke, when piston again moves from bottom dead center to the top dead center, and when crank completes next pi rotation or 180-degree rotation, there is a compression. The black color line, dark black color half circle is nothing but the compression. During this process, piston moves from bottom dead center to the top dead center, and during this both the valves are closed. Inlet valve is also closed and exhaust valve is also closed. In compression, the fuel air mixture in case of SI engine or only air in case of CI engine gets completes. At the end of the compression stroke, there is a IS, ignition starts, or fuel injection. In case of the SI engine, there is a spark plug is provided, and due to the spark there is a ignition of fuel will start. Or in case of CI engine, there is a fuel injection. The water air we have compressed, in that fuel is injected, and due to its temperature the combustion starts. So somehow in both the cases, SI engine and CI engine, the ignition start when piston reaches to the top dead center. Due to ignition of fuel, there is a explosion and there is a pressure rise takes place, and due to this piston is forced to move from top dead center to the bottom dead center. And you can see the red color half circle next pi rotation or 180-degree rotation is nothing but the power stroke or the expansion of the combustion flue gases due to combustion. During this third stroke, piston moves from again top dead center to the bottom dead center, and during this stroke also both the valves inlet as well as exhaust are closed. Due to this explosion of the fuel, there is a pressure generated and which forces the piston from top dead center to the bottom dead center, and that's why it is also called as the power stroke. This is the only stroke where the power is generated, and in remaining stroke the power is utilized. Third stroke is completed when piston reaches to the bottom dead center. Now here you can see EVO. When piston reaches to the bottom dead center, there is a exhaust valve open. So exhaust valve will get open and piston starts moving from bottom dead center to the top dead center. During this movement of bottom dead center to the top dead center, the volume of the combustion go on decreasing, and as exhaust valve is open, the flue gases or the exhaust gases start moving outward through the exhaust valve. During this movement of the piston from bottom dead center to the top dead center, this volume of combustion go on decreasing and flue gases come out. So this way the crank completes its two rotation, that is 720-degree rotation, and piston completes its four stroke: suction, compression, expansion and exhaust. So here in this diagram you can see during first stroke inlet valve get open, and at the end of first stroke inlet valve gets closed. During second and third stroke both valves are closed, and during the fourth stroke exhaust valve is open and it gets closed at the end of fourth stroke. So this is nothing. So students, here we have seen the theoretical wall timing diagram. So in next slide here also it shows the theoretical timing wall timing diagram. The theoretical wall timing diagram has opening of valves and closing of valves, inlet and exhaust are exactly when piston is at top dead center and bottom dead center. Now in next slide we'll see what is difference between theoretical wall timing diagram and actual wall timing diagram. Now in this diagram, you can see the wall timing diagram for 4-stroke petrol engine. In case of the 4-stroke petrol engine, as it is a petrol engine, we know during the suction stroke, air fuel mixture is taken inside and then it is compressed in the compression stroke. At the end of compression stroke, there is a spark plug which starts ignition, and then there is a power stroke, and finally there is a exhaust stroke. So we'll start from the very first stroke, that is suction stroke. During suction stroke of the 4-stroke petrol engine, again you can see the green color innermost half circle is nothing but the suction stroke. Suction stroke starts when inlet valve opens, and suction stroke starts when piston starts moving from top dead center to the bottom dead center. But here you can see the inlet valve is open before piston reaches to the top dead center. Approximately the valve is open 15 degree before the piston reaches to the top dead center, and suction of air fuel mixture starts inside. During the same, the exhaust stroke is also continue, means inlet valve is also open, and due to the inlet mixture of air fuel, these products of combustion moves out, means this inlet pressure also helps to move out the gases from the combustion chamber. So when the inlet valve open before piston reaches to the top dead center 15 degree before as shown in figure, the fresh charge starts coming, and when piston reaches to the bottom dead center till the inlet valve is open. When piston reaches to the bottom dead center, theoretically valve should get closed, but you can see in the diagram inlet valve is closed when piston reaches to the bottom dead center, and it is open till crank completes next 30-degree rotation. At this the green line ends, you can see the inlet valve gets closed, and then actually the compression starts. So the black color line shows the compression of the air fuel mixture, and piston reaches to the top dead center. During this there is a compression continues. Then theoretically the spark should be given when piston reaches to the top dead center and when compression stroke is completed. But you can see IS, ignition start. This ignition started because the spark is given and it is 35 degree before the piston reaches to the top dead center. Because when spark is provided, some time is required to actually start the combustion of gases or combustion of fuel. That's why the spark is given well before the piston reaching to the top dead center. So almost when piston reaches to the top dead center, combustion starts, and due to the combustion, pressure starts increasing inside the combustion chamber and it forces the piston from top dead center to the bottom dead center. The red color line, you can see it is nothing but the expansion or the power stroke. Power stroke should continue. Power stroke should continue when the piston reaches to the bottom dead center, but you can see the exhaust valve gets open well before the piston reaches to the bottom dead center because the pressure rise is very high due to the combustion of gases and inlet valve gets open before the piston reaches to the bottom dead center. Here in diagram it is shown 50 degree before the exhaust valve gets open. And exhaust valve is open when piston reaches to the bottom dead center and again moves from bottom dead center to the top dead center and till it is open when it completes 20 degree more rotation, means when piston starts moving again from top dead center to the bottom dead center. After that also, after TDC also, 20 degree after that exhaust valve gets closed. So here you can see the inlet valve and exhaust valve are not exactly opens and closed when piston is at top dead center and bottom dead center. They are get opened well before the piston reaches to the top dead center or bottom dead center, and they also get closed after top dead center and bottom dead center. This is the main difference between theoretical valve timing diagram and the actual valve timing diagram. So in this next slide, you can see the valve timing diagram of 4-stroke diesel engine. Here also you will find the same things, that inlet and exhaust valve are not closed and open exactly at the dead centers. They get open well before the dead centers and they get closed some time after the dead centers. The values here shown, that 5 degree, 25 degree, 45 degree, are the symbolic representation. Valve when get open and when get closed after and before the dead center, it depends on the speed of the engine. In case of the high speed engine, this lag is higher. In case of low speed engine, this lag is less. So in figure, the symbolic representation are shown. These are not true for all types of and all speed of engines. Depending on the speed, this will get vary. Now here in case of the diesel engine, the difference is that in case of SI engine we have spark plug, in case of the diesel engine we have the fuel injectors. So again we'll start from the front. You can see here the understanding will be make simple, because it starts exactly from when inlet valve get open and it will end when the exhaust valve will get closed. So here you can see the inlet valve is open 25 degree before the piston reaches to the top dead center. So suction stroke starts from that point and inlet valve will get closed after 30 degree when piston reaches to the bottom dead center. Here the suction stroke is completed. Then there is a compression of air. Then at the end of compression, before piston reaches to the top dead center, 5 degree before that, you can see in the diagram, the fuel injection starts, and the fuel injection is continued till the piston moves from top dead center and started moving to the bottom dead center. Because fuel injection is not an instantaneous process, it will take some time, and during that time you can see the piston moves 5 degree before top dead center to the 25 degree after top dead center. Means during this 30-degree rotation of the crank, the fuel injection continues. After fuel is injected inside the combustion chamber, due to the pressurized air, already the temperature is increased, and due to this temperature there is a combustion starts in case of the CI engine. Then Due to the combustion of fuel, there is a expansion or the power stroke. Then before piston reaches to the top dead center, exhaust will valve will get open 45 degree before the bottom dead center, and it is open after the top dead center, before after the piston reaches to the top dead center also. That is not shown here in the diagram, but you can see in the previous slide it is shown the exhaust valve is open after the piston reaches to the top dead center also, until there is a expansion stroke. So in these diagrams you can see the inlet valve and exhaust valves are open for simultaneously for some period of the time, and this suction and exhaust is the simultaneous process during this time. So in this new slide, you can see the difference between theoretical and actual valve timing diagram for 4-stroke diesel engine. In the left diagram, which is the theoretical valve timing diagram, you can see the inlet valve open, inlet valve closes exactly as top dead center and bottom dead center respectively, and exhaust valve opens and exhaust valve get closed at bottom dead center and top dead center respectively. Whereas in the right side diagram, where the actual valve timing diagram, the valves are gets opened and closed before and after the top dead center. So this is required to match with the speed, because the speed of the engine is very high. It is not exactly possible and it is not convenient also to start and to open and close the valves exactly at top dead center and bottom dead center. Also, it is some time is required for the starting of the combustion, and that's why the spark plug or the spark is given well before the piston reaches to the top dead center, or the fuel injection starts well before piston reaches to the top dead center. So here in this video we have seen the wall timing diagram, theoretical wall timing diagram, and the practical wall timing diagram. We'll meet in the next lecture. Thank you.